Hi, this is Electrical Engineering Bootcamp and, in this video, I am going to go over Fukushima Nuclear Water Release and I will separate the facts from the fears. Let us get started.
Before me dropping value bombs of this video, I would like to introduce the Nuclear Power Engineering Principles course, now available on Udemy. This comprehensive course is your ticket to mastering the principles of nuclear power engineering and taking your career to new heights. Packed with engaging lectures, this course is designed to provide you with a deep understanding of nuclear power engineering principles. And the best part, upon completing the course, you will receive a prestigious certificate of completion to showcase your newly acquired skills and knowledge. It is a valuable credential that can open doors to exciting career opportunities in the nuclear power industry. Don't miss out on this incredible opportunity to unlock your potential with Nuclear Power Engineering Principles course. Enroll now and gain access to this top-rated course at an unbeatable price. But hurry, as this offer won't last long. Join us today and take the first step towards a successful career in nuclear power engineering. Enroll now in the Nuclear Power Engineering Principles course on Udemy and unlock your potential. Don't wait and start your learning journey now. Now, if you're interested, the link to this course is provided in the video description below.
The impending release of treated water from Japan's Fukushima Daiichi nuclear power plant into the Pacific Ocean has sparked a global debate. This critical issue has been clouded by scandals, a lack of transparency, and a trust deficit between the public and the authorities. Amidst this controversy, it's crucial to examine the facts surrounding this decision and its potential impact. The Fukushima nuclear plant has faced the colossal task of cooling its reactors since the 2011 tsunami disaster. To accomplish this, it requires 170 tons of cooling water daily. Additionally, rain and groundwater have infiltrated the site, resulting in 1,046 storage tanks containing 1,343 million cubic meters of water. After filtration, this water is considered safe and will be released into the ocean over approximately 30 years. The radioactive waste will remain on land. Both Japan's Atomic Agency and the International Atomic Energy Agency, IAEA, have approved this plan, stating that it meets international safety standards and poses a negligible radiological impact on the environment. It's worth noting that releasing used cooling water into the ocean has been a common practice globally for decades. However, concerns persist among environmentalists, fishing experts, and neighboring states about the accuracy of radiation levels. Before its release, the contaminated water will pass through the Advanced Liquid Processing System, ALPS, capable of filtering 62 different radionuclides but not tritium. TEPCO aims to dilute the water until tritium concentrations are within safe limits. Tritium, a radioactive form of hydrogen, is far less dangerous than other radioactive isotopes like cesium-137 or strontium-90. It emits weak beta particles easily stopped by common materials. Experts, including radioecologist George Steinhauser, assert that releasing tritium in diluted form poses minimal risk to both humans and the environment. The Pacific Ocean's vastness acts as a natural diluent, following the principle that the solution to pollution is dilution. Experts emphasize that once tritium is diluted to safe levels, it poses no significant threat. Critics, including Greenpeace, argue that focusing on tritium distracts from other remaining radionuclides, such as strontium-90 and iodine, which won't be filtered to undetectable levels. They also highlight that ALPS cannot remove carbon-14, another radioactive element. Environmental groups suggest alternatives like additional storage tanks or allowing water to evaporate. However, concerns about earthquakes in the region make additional tanks risky. Evaporation, while feasible, carries the potential for uncontrolled releases into the atmosphere. Many experts, including Steinhauser, assert that releasing water into the ocean is the safest solution. It prevents groundwater contamination and ensures controlled, gradual dispersion of tritium. The Fukushima water release plan is fraught with complexities and concerns, but understanding the facts is essential. Tritium, though radioactive, is relatively benign when released in diluted form. The vastness of the Pacific Ocean acts as a natural safeguard. While alternatives exist, experts widely support the ocean release as the safest option. As this crucial decision unfolds, it's vital to continue scrutinizing and discussing its implications. We must prioritize transparent communication and engage in informed dialogue to address the concerns surrounding this critical environmental issue.